Imagine our solar system drifting through space, unaware of a silent, invisible predator, a rogue black hole. These cosmic nomads are the remnants of massive stars, born in violent supernova explosions. Sometimes the explosion is so forceful it hurls the newborn black hole into the galaxy, untethered and alone. These solitary hunters travel at incredible speeds, invisible to our eyes, their presence betrayed only by the subtle warping of space-time. We gaze at the stars, but between them, these ghosts glide, capable of disrupting entire solar systems. The threat isn't a collision, but gravity. A black hole's pull is so intense, not even light escapes. Its influence stretches far, casting an invisible net across space. An encounter would be a slow, relentless unraveling, not a sudden crash. Our solar system could be torn apart, planets flung into chaos, all by a force we'd never see coming. The universe is beautiful, but it hides dangers as silent as they are devastating. This is the story of the ultimate cosmic hunter. A rogue black hole isn't a void, it's a star's corpse, compressed into a point of unimaginable density. Picture the mass of our sun squeezed into a sphere just a few kilometers wide. This creates a gravitational field so powerful it forms a one-way door. The event horizon. These black holes are born from the explosive deaths of giant stars. Supernovae rarely explode evenly. A lopsided blast can launch a black hole out of its birthplace at incredible speeds. Once ejected, it becomes a wanderer, drifting through the galaxy for millions or billions of years. It emits no light, reflects nothing, and is nearly impossible to spot directly. We search for their presence by the effects they have disturbed orbits, missing light, subtle gravitational clues. Finding one is like hunting a shadow in a sea of darkness. Yet these invisible travelers are out there, moving silently through the cosmic night. Their journeys are long, lonely, and almost undetectable. But their power is absolute, and if one ever crossed our path, we'd only know by the chaos it left behind. Black holes are invisible, but their gravity reveals them. According to Einstein, massive objects warp space-time, like a bowling ball on a trampoline. A black hole creates a well so deep, even light must curve around it. When a black hole passes in front of a distant star, its gravity bends the starlight, creating a phenomenon called gravitational lensing. Sometimes this forms a perfect ring of light, an Einstein ring, a fleeting ghostly halo. More often, the star simply brightens and fades as the black hole passes by, a subtle flicker called microlensing. Astronomers scan the sky for these brief brightenings, searching for the invisible. If a black hole feeds on nearby gas or a star, it forms a glowing accretion disk, lighting up in X-rays, a rare but unmistakable sign. Most of the time, though, they remain hidden, their presence betrayed only by the way they bend light and warp the universe around them. Our best hope of finding them is to watch for these gravitational whispers. The hunt is painstaking, but the stakes are cosmic. In the darkness, gravity is the only clue, and sometimes that's enough. Imagine astronomers detect a star in Ophiuchus brightening in an unusual way. Telescopes reveal a perfect ring of light, an Einstein ring, caused by a nearby rogue black hole. The realization is chilling, it's heading toward us. At first, only sensitive instruments notice the change. Tiny shifts in the orbits of Neptune and Uranus. The Kuiper belt becomes chaotic, sending comets cascading toward the inner solar system. As the black hole approaches, its gravity distorts the moon's orbit, causing extreme tides and unpredictable seasons on Earth. The constellations begin to drift, the sky warps, and stars stretch into arcs of light. The night becomes a surreal, shifting spectacle, a warning written across the heavens. The laws of physics seem to bend before our eyes. The universe announces the arrival of a new, dominant force. Our solar system's stability, once taken for granted, is now in jeopardy. The warning is clear, but the outcome is uncertain. The silent hunter draws near. As the rogue black hole enters the inner solar system, chaos erupts. Saturn's rings are shredded, Jupiter's moons are scattered, and planets are flung from their orbits. On Earth, earthquakes and supervolcanoes devastate the land, while the sun's image warps in the sky. Our planet's orbit unravels, either captured by the black hole or ejected into the cold void as a rogue planet. The warmth and light that sustained life fade away, leaving a frozen, lifeless world. The solar system's delicate balance, stable for billions of years, is destroyed in months. Planets, asteroids, and comets are cast into chaos or lost to interstellar space. The solar system as we know it ceases to exist. All of this, orchestrated by gravity alone. The black hole doesn't need to consume us. Its presence is enough. The end is silent, complete, and absolute. The universe reclaims its own. How likely is this nightmare? Thankfully, it's extraordinarily rare. The Milky Way may hold millions of rogue black holes, but space is vast. Our solar system is a tiny target. The odds of a close encounter are vanishingly small, and our ability to detect these objects is improving. New observatories will give us centuries, even millennia, of warning if one ever approached. The study of rogue black holes isn't about fear. It's about wonder and understanding the extremes of our universe. They remind us of the power and beauty of cosmic forces. For now, our place in the galaxy is safe. The night sky remains a source of awe, not dread, and we are free to look up and marvel at the mysteries above.